So a reminder that a geometric sequence is when you're multiplying each time, and a geometric series would be when you're adding them up. And if we took 2 plus 10 plus 50, can you see that my r in this one, I'm multiplying by 5. So if I wanted to come up with a shortcut above this, I'm going to take the same sum and multiply it by 5. And what that would do is it would take my 2 and it would change it to a 10. My 10 would change to a 50. My 50 would change to a 250. And my 250 would change to 1,250. What that does is allows me to subtract this whole thing. And if I subtract this whole thing, 5 sums minus 1 sum would leave me with 4 sums. And here, if I subtract, the 10s would cancel out, the 50s would cancel out, I would get 1,250 minus 2. And so my actual sum, if I subtract that, would be 1248, and I'd have to divide by 4, and I'd get 312. This would be if I was multiplying by 5. To come up with a formula, we do the same thing, but in a general idea. So a normal sum starts with term 1. Then you, since it's geometric, you'd multiply by r and you'd have r times term 1. Then you'd multiply again by r, right? And you would have term 1 r squared. And I'm going to write the term 1 first because that's how our formula has it. Because eventually you would get to the last term, which would be term 1 r to the n minus 1. And in this case, obviously, my r is equal to r. Like the first one, our r was 5. This time our r is just r. So I would take my sum and I'd multiply it by r. What would that do? That would take my first term. If it gets multiplied by r, it would be r times my first term. And it would take this one, if I multiplied it by r, I would get term 1 times r squared. And I would keep going, and all of these would be the same until I got to the last one, which would be r n minus 1, and I'd have to multiply one more time. One more time would give me r to the n. And again, if I took this whole thing and I subtracted, you would see that all of these middle ones would cancel out. And r of them minus 1 of them would give me r minus 1 of them. Does that make sense? When I did 5 minus 1, I got 4. Now when I do r minus 1, I would get r minus 1 of them. And here, I would get term 1 r to the n minus term 1. Those are the only ones that are left. And I can get my sum by itself. Now, on your formula sheet, it doesn't look exactly like this. What your formula sheet has is your formula sheet has a 1 minus r on the bottom instead of an r minus 1. In order to get 1 minus r, I would have to take out a negative 1 on the bottom. Because if I factor a negative 1 out of r, I get a negative r. And if I factor a negative 1 out of negative 1, I get a positive 1. On the top, if I factor out a negative term 1, that will make this negative term 1 a positive 1. I'm going to write that first because that's how your formula sheet has it. And if I take a negative term 1 out of this, I would get a negative r to the n. Now your formula sheet says, well, a negative divided by a negative, those would cancel out. And also on the bottom of page 44, they have that formula. You might ask, well, why would they change the formula? Isn't it like, why couldn't we just have had the formula we had before? This is exactly the same formula. And some textbooks have that exact same formula without the negative 1 factored out. Okay? They both give you exactly the same answer. The reason they have the formula in the blue box is because of something we're going to do in 1.5, and then that formula is nicer if it's in that form. But as far as where we got the formula from, it's probably easier to see the way that we did it rather than the way the textbook has done it, because it's more confusing to subtract backwards, I think. So with that idea, we have this formula. We can now answer some questions. So here's question number 1. Determine the sum of the first 12 terms in this geometric series. So you would go to your formula sheet and you would write out your formula, and then we want to find the sum of the first 12. Do you know term 1? Yes. Our term 1 is 3. Mental math, can you tell what you're multiplying by? 4. Perfect. And since n is 12, this will be 4 to the 12 over 1 minus 4. Now, if you have a graphing calculator and you have a bunch of numbers to plug in, I would like you to get used to typing it in all at once. And if you have the newest version of the graphing calculator, then I'll show you that you should use the fraction button. If you have an older version that doesn't have the fraction button, you're going to just have to type it in with brackets. So what I'm going to do is, if you have the fraction button, you'll be able to hit the alpha button and y equals, and the fraction will appear. Then you can type in exactly what we had. So we had a 3 bracket 1 minus 4 to the exponent of 12. Now when you get up to the exponent of 12, you're going to have to hit over to come back down. Close that bracket, over 1 minus 4. So we can type in exactly what we had there and push enter and get our answer, which is a very big number. So if you have the ability to type it in all at once, that's perfect. Whatever calculator you're using, some of you are using scientific calculators, you want to make sure you're comfortable with the calculator that you have to be able to type it in and get the answer. Okay, take 5 minutes and try questions 4, 5, 6, and 7.